Hey, Nathan here from PH Studios, and welcome back to another Tower Defense Engine tutorial. In this video, we're going to cover the very first step in our map class, the one that we've been waiting for before continuing to step 2 on all the other classes we've done in the past. So in this video, we're going to do the first part of the map class, and then the next tutorial, we're going to talk about the map loader, and then we'll go on to the previous classes we've done before, and actually do part 2 and fill in those methods that we've just created the headers for. We're just getting things started and getting all of our class structure going, all of our methods and properties for the next step, which will actually fill in these methods and complete these classes. So after this video and the map loader video, we should be about halfway finished with this engine series. Now, as I was starting the development for this game about 2 years ago, I knew it would not be done in a week or 2 weeks or anything like that. I knew it would take 2 years, and I knew I would have to stop development for like 4 months and focus on classes or anything like that. So the way I designed the game is the way that you're following my video here, is I wrote on pencil and paper what the classes were, what their methods and properties were going to be, and how they were going to be connected. And then, after that, I filled in the method bodies, just like what we're doing here. So that's why we're following this process of doing part 1, where we create all the properties and method headers, and we'll fill in the method bodies on part 2. Alright, so this is the map class, and there was a request that we don't really need to see the whole Visual Studio window here, so I'm just recording the editor and what you'll need to see here. But you'll see I'm in the map class here, and we can just focus on the editor. So that way it's a little bit better quality, and we don't need to see the file menu at the top or the Solution Explorer, and I might just simply do this and show it to you. So anyway, let me get this all sorted out again. I had it positioned perfectly before. Alright, so at the very top you'll notice a few using statements. Just add the ones I've highlighted here, and I'll read those off to you. We need to add Microsoft.xna.framework, Microsoft.xna.framework.graphics, Microsoft.xna.framework.content, System.io, System.xml.serialization, Microsoft.xna.framework.content.pipeline.serialization.compiler. That is a long using statement right there. Alright, so at the very top, right before our public class, we're going to have a way to do the, we need to have a way to manage the, to determine the map state. And we need to determine if it's in the current state of the map. If we're in a wave delay, you'll notice when you play the game, it'll say at the bottom of the screen, wave X in 10 seconds, 9, 8, and so on. So that will identify that the map is in a wave delay, and then we can perform that wave X will start in Y seconds. So we have a wave delay state that will be used to just delay the monsters and give us that user interface feature that you noticed. And then we have an active state when we're in the middle of an active wave where monsters are actively being spawned from the spawner and trying to reach your destination. That's an active state. And of course, whenever you beat all the waves or you have no lives left, then it becomes an finished state. So we need those 3 states in a public enumerated type. Map state. And then we have wave, delay, active, and finished. And these are just the wave states. You can add more states later that centers on your game, or you can just leave them the way they are. Alright, so now for the properties. By the way, I apologize if my microphone settings are either too loud or too soft. I'll double check that in the editor, and I'll do whatever I can. I just got a solid state disc, my second solid state disc. The first one I had didn't really work out that well, so I didn't really use it. But I bought a new one, and I got everything else set up, and I just need to get my settings back to the way they were. Alright, onto the properties. Like always, we will have a content serialization, and if we need it in the XML, we will have just content serializer. If it should not be in the XML, you will have content serializer ignore. Then we have a public property for the map state. The XML does not need to be aware of the map state because it's an internal state of the map. It's determined by what the current status of our game is. Alright, so we have get and private set. Also, somebody asked me a question on YouTube, or I think it was email, why I use properties more than I do fields. You know, the just simple public map state semicolon. So why do I do all these properties? Basically, it's just to be consistent. I want classes to be look the same as any other class. And the other thing is, it gives me more precision. I can either public get and private set, or I can customize each get and set. That way I don't have to create a getter and setter method to go along with each field. It's just personal preference. Alright, so now we need to name the map. You saw when you play the game, you have a forest map, snow map, or a vector map as of Tower Defense 1.1. So that's what we will have as the name. And it's a string. We can name it forest, snow, vector, or whatever else you want to call it. And we will private set. Now the dimensions, how many tiles in the X and Y, how many tiles it supports in both X and Y. And there's no way we can have half a tile, so we're going to use the point structure. Point, capital P, for dimensions. And that will allow us to use integer for X and Y. Alright. Now tile dimensions. Again, we'll have a point, and each tile will have a set amount of dimensions. Is it 32 pixels by 32, 64 by 64, whatever we decide. Alright, so now when you're at the level selection screen on the game, you'll see you can select which map, and at the very bottom it'll say, this is a map with a forest theme. That is the description of the map. We can customize that, and we can say whatever we want, and it will be a string. Okay, again, when you're in the level selection screen, when you look at the map, you will have a little picture of what that map will look like, and that's going to be a thumbnail that we will add in our properties. And I made it an optional field, so do not necessarily have to have it. So in order to do optional, if you don't remember how to do that, we have content serializer, opening parentheses, capital O, and the rest of optional, so it's optional with a capital O at the beginning, is equal to true. Closing parentheses and the closing bracket. It's a private string, and it's the thumbnail asset. It's to get to the picture file that we made in Photoshop or whatever. And the reason I'm doing private here is because we do not need to know the asset name outside of the class. The session does not need to know when we call map dot. We do not need to know the thumbnail asset in any other class other than the map class. But it does need to be in the content serializer, so it does need to be in the XML. But it's completely optional, as this says it here. Alright, so anytime we have an asset, we need to have the actual object that goes along with it. So we need a texture 2D for thumbnail. And it's going to be get and private set. And that's going to be ignored. We don't write any textures to the XML. That's the reason why we have assets. Okay, now each map looks differently. And the reason it looks differently is because each map has its own tile sheet. A tile sheet gives us what each tile looks like. The path that the monsters take. The grass in the forest map, or the snowy grass in the snow map. So we're going to content serialize the asset for the tile sheet, and it will be optional, so do like we did at the top, and set it to optional. And it's going to be a private, again, string, tile sheet asset. Now we will ignore what goes with it, and that's the texture 2D. Public. Texture 2D tile sheet. Get and private set. Alright. So when we go into the actual coding, we need to be aware of how many tiles are in the sheet. How many tiles are in the X direction and Y direction. Is it 4 tiles wide and 2 tiles tall, which make it 8 tiles total? We need to be aware of each representation on the maximum tiles in the sheet. So public. Oh, this will be ignored. And it will be public point. Number of tiles in sheet. Get and private set. And this is going to be ignored. We're not going to add it to the XML because we can use mathematics and use the tile sheet here to determine the number of the tile sheet and the tile dimensions here to determine this. Alright, now, when we have an actual map, we need to generate how it's going to look in the XML file. So how does the base map look? Do we have trees in the map? Where are we going to put the tree tiles? That will all be done in the XML file, and it will be done in an integer array. Now that will be the base layer. We're going to call that the ground tiles. We have ground tiles, and then we have path tiles. So we're going to serialize those. Public int, opening and closing bracket, is an integer array. Ground tiles. We're going to get and private set. And now we have path tiles, but I'm going to set this as an optional one for a later patch where we have fully A-star implemented to where we don't have a set path for the monsters. That will be in a later patch. Public int path tiles get and private set. Alright, regardless if we have a set path or in a later patch where we don't have a set path, to where most tower defense games operate the way that you create your own maze that the monster can follow. Regardless of which way we are going to have that functionality, we do need to have an active path, and this will be ignored because we will have the map class itself determine the active path. And it's a path object, get and set. Alright, onto the house and spawn locations, where the monsters will spawn from. We'll call that the spawn location, and where they will be going towards. And we'll call that castle or house or something like that. Public point spawn location private set. And now how does it look? What is it, a house that they will spawn from? Is it like a gate? So each map can have a different look to the way that the monsters spawn from. So we're going to have a texture that goes along with that. So just like always, whenever we want to get access to a texture, we need to set the asset name in the XML file. Spawn asset name get and set. Then let's ignore what goes along with it, and we're going to automatically create a gameplay object that goes along with that spawn object. Get and private set. Same thing for the house or castle or whatever you want to call it. So I'm just going to copy these three properties here. I'm going to paste them below. And I'm going to change those to castle or destination or friendly or house or whatever you want to call it. Okay. So now that we have the spawn and castle location, let's get this thing ready for the endless mode. And what endless mode will do is, if it is true, it will automatically replay the waves. It'll just keep on going endlessly until you decide to quit. If it is not true, whenever you reach the last wave, you're done. It'll give you the game over screen that we will implement in probably version 1.3. But for now, it'll just say, it'll take you back to the map selection screen. Alright, so each map can give you access to different amount of towers that you can choose from. The forest map only gives you the basic tower. The vector map gives you the basic tower and poison tower. The snow map gives you the basic tower, poison tower, and bomb tower. So each map lets you choose a different amount of towers to choose from. And this is done with a list. but it's a list of strings, and those are going to be the tower assets. So towers available. That's what we can choose from. Now we will ignore what goes along with it, which is the actual list of tower objects. Public list tower, tower list. Get and private set. Now we will ignore the next property, and just like with the session and using the user interface, we're going to automatically create a string for the tower's info. How many towers we have. So as you see in the map selection screen, it'll say towers 2 or 3. So we'll actually set that string so do not have to create that string object every loop. Okay, now we're going to do the exact same thing, but for the waves. We have the towers, now we need to get to the waves. Each map can have a different set of waves. So we have a private list of string for waves available. And those are the asset names, and they'll be in the list format. Alright, now we will ignore what goes along with it, and then is the actual list of waves. Public list wave list. Get and private set. Now we want to give the programmer control on how to delay the waves. If we should let the person playing the game have a minute to manage their towers before each individual waves, or if you want to make it a really difficult map and that only like 2 seconds you get to do something with. So that will be up to the programmers, and we'll give them access to change that in the XML, and that will be a float wave delay. Now we will ignore what goes with that, and that will be a public float timer. Alright. Now we have access to the list of waves we can have in this map. What we do need access to additionally is what our current wave is. We have 10 waves, we need to know which wave we are on right now. And that will not be in the XML because, well, obviously it'll always start at 0, so we don't need to have it in the XML. So we will ignore it, and it'll be a wave index of type integer, and get and private set. Not only do we need to know the index, but let's get in reference to the actual active wave. We need to have access to the index because when we create that string in the user interface where it says wave x of y, that's where we will reference the wave index. So public wave, active wave, it's going to be get and private set, and the actual waves info, where we say waves : 10, So this map contains 10 waves. And it is a string, just like the towers info, where we say towers : 3 to say this map has 3 towers. And you can customize this if you want to. In my version, I just have it say towers : 3 or towers available : 3. If you want to actually list out the names of the towers, you can do this. Just modify the way that these are being set up, and you can change the way that your game looks. Okay, we're getting close to the end of the properties. We just have a few more left to do. And the next one up is the difficulty. We're going to leave that up for the programmer to list the difficulty, and it'll be up to them to set their own scale. If it's in a scale of 1 to 10 or 1 to 100, it's up to the programmer. But they will actually set the difficulty in the XML file to say this is difficulty 2 or difficulty 3 or whatever the programmer wants to say. Now what goes along with that is, again, just like the towers and waves, it'll be a public string difficulty info. Get and private set. Now, whenever you start a map, you will get a big chunk of money to buy a lot of towers with. Now that's at the very start of the map, so the map controls how much money you start out with. Now this is a field because I'm going to create a property that goes along with it, so we can perform additional logic whenever we set the data. We can automatically set the money info, which will be next. So let's go ahead and do content serializer. This will be available in the XML. And let's make it a public int money. And we'll have get opening curly brackets, return money, semicolon, closing curly brackets. Now be careful on the case here. Always go for the field. If you put in a capital M at the very beginning, it'll make an infinite loop here. So just be careful on that. Set opening curly brackets, money is equal to value, semicolon, closing curly brackets. Now let's go ahead and create the money info, and then we'll finish the money property up here. Public string money info, get and private set. Alright, go back up to the money property, and after value semicolon, press enter. And let's set money info is equal to capital string dot format. Just the capital S in string, opening parentheses, double quote, money, colon, space, opening curly brackets, 0, closing curly brackets, end of the double quote, comma, money, end parentheses, and semicolon. Alright, so anytime this property gets set, it'll automatically change the money info string, so we do not have to do that in a different method or something like that. Now we're on to the user interface elements. We need to have access to the for color, the air color, if it's like a green for color for the forest map, and red is the air color. We need to have access to that. And then what do our buttons look like? Each map can have different looks to the buttons. So these are all the user interface elements, and that will be the rest of the properties, it looks like. And then we also have something for the music. Alright, so let's get started with these properties. So first thing up is the forecolor. What is the color we want to give the text on this map? Now the way that I did this is a little bit of a workaround. We could not easily write the color data to the XML file. I would have to create my own color class or a whole bunch of stuff to get that to work. So instead, I used an integer array for the color. Now, I set it to a private integer array because I do not need access to the actual array. What I do need access to is a color object that it represents. This was the easiest way to get around the issue of writing color to the XML, and I just decided to use an integer array. And the integer array is represented by RGBA, so it'll be 4 integers. So you can customize the way it looks and even give it an alpha value. Now we will ignore what goes with it, and that will be the actual color object. That one we will want access to, so it'll be public access for color. Get and private set. We will do the same thing for the error color. We will ignore what goes with that because we will want to get that. And it will be a color as well. Get and private set. Okay, so onto the more user interface elements themselves. We need to customize the way that the info bar looks. Each map can have a different look to the info bar, and that will be using a asset for the background color, or the background texture rather. And we already did content serializer. Now we do not need access to the asset for the info bar, so that's why I set private string. Info bar background asset. You can have a different background for different maps and it will look completely different. We will ignore what goes with that, which will be the actual texture 2D. Alright. If you remember the user interface tutorial when I went through the user interface elements, we discussed the UI block. Now the UI block has a border around the right, and then the top right, and then the bottom right. So that border, I can customize the way that that border looks. And we will serialize that private integer array border color array. Now we will ignore what goes with that is the actual color object. Public color border color. Get and private set. We also need the border texture. Public string. Anytime we have a texture, we want to write the asset to the XML file. And that will actually be private string. We do not want access to the asset name. We just want access to the actual texture that goes with it, but we will ignore it from the XML. This will allow us to create the little fade effect I created in the borders. If you see the actual game here, you will see that the top right border fades out to the background. That's the texture we will use in order to create that little fade effect. So this is why we are creating the border texture. Alright, now we need access to the mouse. Each map, you can customize the map to have a different looking mouse from one map to another map. So we will serialize the mouse texture asset. But we will ignore what goes with it, and it's the texture 2D. Get and private set. In a previous video, we discussed the user interface elements, and we discussed the map region. Whenever we select we want to buy a tower, the map region will change its user interface to give us a little overlay on where we can place a tower, what tiles are invalid, they will be in red, what tiles are valid, they will be in green, or the actual forecolor and air color of the map, and then where is the spawn location. To determine the green areas, or the map's forecolor areas, to determine the place that we can set the tower, if it's a valid placement, we need to be aware of that. Anytime we place a tower, we need to change a internal integer multidimensional array for a placeable array. So these are placeable towers, or placeable tiles that we can place our towers. Anytime we place a tower in one of the available placeable arrays, indexes, one of the valid placements, we need to change that from valid to invalid. We have all these properties and fields and stuff that goes with them in order to make it easier on us in the actual algorithms. Every time we place a tower, or every time we click buy a tower, we don't need to recalculate what's placeable and what's a valid placement. We can store that in a multidimensional array, so we can just save ourselves with it later calculating it. Alright, so now let's serialize the actual buttons now. We're up to the actual buttons. Private string, small error, button, texture, asset. Now, if you click a button, like let's say you click buy a tower, it's in the map's forecolor, it looks fine, you can click it, but the minute you reach a money amount that you cannot buy the button, or cannot buy the tower, the button will change to an error state. That's where this comes in. It's an error button texture that will only show up if you cannot, if you don't have enough resources, or if the map is not in a specific state to support that function that you're trying to do. The same thing with increase the speed and decrease the speed. If you're trying to increase the speed and you're already at the maximum, you will have the error button. Okay, so now we will ignore what goes with it and the actual texture. Small error button texture. Alright, so we're going to do that a couple more times. Now I'm going to go ahead and copy the code here and paste it below. Trying to speed things up a little bit. Alright, so small error button, that's what we just did. Now create the same two properties for the small error button that you did above, but let's change it to small normal. Alright, copy those two properties again, and let's change it to large error. Copy those two again, and let's call it large normal. So we should have 4 buttons and 2 properties for each button. So we should have 8 properties here. We should have small error button texture and then the asset that goes with it. Small normal button texture and the asset that goes with it. Large error button texture and the asset that goes with it. Large normal button texture and the asset that goes with that. Alright, we have one more property left to do. And that's for the music. Again, we want each map to give us a completely different experience if the programmer wants to achieve that. Now, I only have 2 different song cues in my game because I did not have time to create 10 different songs for each level. So I just decided I'll create 2 song cue names. One for the forest map because there's a forest theme that goes with that map. And the other song cue name will be for the other maps. Now, I'm sure that since this game is done, I can create more music and we can have a completely different set for the forest map, a completely different set for the snow map, and so on. But for now, for my game, there is not really that much difference between the music. But it's better to have options, and I'm building this tower defense engine so not only I can use it, but you can use it too. So that way, if you have 30 songs and you want to create 3 maps, you can have a completely different song set per map. So that's why we have this property here. Alright, now let's create an event for when there is a new wave. When there's a new wave, we need to signify that and let the user interface know, like the wave information user interface, we need to let that know that we have reached a new wave and it needs to update its display, its string. Alright, so now onto the methods, and then that will be it for this tutorial. It's reaching its... I really don't like having tutorials run for 40 minutes. So public map the constructor, open and closing curly brackets, public point to world coordinates, and then the tile that we want to convert. Alright, so let's go ahead and set this up. We have a point result is equal to new point return result. Alright. Another one. Point. Oh, it's public point to world coordinates, and we pass it int x, int y, And what this will do is we have a point here for this one and this one. We have a way that we set, it'll give us a map, we pass it map coordinates and it'll convert it to world coordinates. So if it's 3, 4, it'll be the fourth row and then the third column tile. And we need to convert that to the actual world coordinates, like 300 by 250, and that will give us a result. So point result is equal to new point return result. Now those are for world coordinates. Now we need a public point to map coordinates int x, int y. Point result is equal to new point and return result. And of course, anytime we have any map that should... Anytime we have a map that has like timers and stuff like that, we need to have an update method. So we update and we pass a game time, and then where we also have states, where we have the map states at the top. Remember, that's what we had in the first part of this video. Public void start next wave now. Whenever you click that button that says send next wave now, we will call this method and it will start the next wave now. So whenever you complete a map and you want to play it again, so you complete the forest map, it'll take you to the map selection screen, or it'll take you to the little menu screen where you can click play again, and you select it again. We need to, instead of reloading that into memory, reading the XML file and resetting everything that way, we'll have an internal reset that will reset everything, reset the states, reset the placeable array, and reset everything back to the original state. That way we don't have to read the XML information again. Public bool is valid placement. This is where we will use the placeable array. Alright, so we'll pass it int x and then int y. And this is the placement, the tile that we want to verify if it's valid or not. So we're going to assume it's false until we prove it is. So bool result is equal to false. Return result. Assume the opposite you're trying to prove when we have a Boolean method like this. You want to set it to the opposite of what it's trying to prove. That way, if we prove it, we set result is equal to true, and then at the very end we will return result. So we test if it's true, and then we return whatever, if it's true or if our original assumption was correct. Public void set valid placement int x, int y, bool b. If we buy a tower and place it somewhere, we're going to set it to a invalid placement. If we sell that tower, it's going to be a valid placement again. So that's it for that method for now. Last one, private void generate placeable array. Alright, we can save this class, and that was it for the map class for part 1. So I hope you enjoyed this tutorial, and I hope you're learning what the map class does as I went through and talked about each property and why I'm using that property, and I hope you got a good understanding on that. And then the next tutorial, I will discuss the map loader. After the map loader is finished, we will go back and finish the part 2 of all the classes we did before. So I know these tutorials have been a little bit boring because all we're doing is setting up the properties and method headers. But once we get the map loader class finished, we will be able to do the more interesting coding and actual logic. So this is the only tutorial I will release this week. I've had a lot of stuff I had to do this week, and this is the only time I got the chance to record something. And this is about a 50-minute tutorial. So, next week, I will discuss the map loader, and then I will perform part 2 tutorials for a couple of the classes we did before. So, we're about halfway done with the Tower Defense Engine series. Once we get all the logic done, that will pretty much be it. So I hope to see you next time for the map loader class, and then part 2, the actual interesting coding, will come shortly after that. So I hope to see you next time.